tell you a story. I won't put a name to it. But my wife once had to our house a very brilliant scientist who sat through dinner which she had prepared, saying nothing. And when she finally said to him, "Aren't you going to say something before you go?" he said, "Look, I don't have to say anything. I'm going to cure cancer."
Curing cancer once seemed like an impossible dream. But some scientists now believe they hold the key: DNA.
There are many, very serious problems facing humans, among them poverty and ignorance. And about these problems, we can do very little. But cancer is a problem that we actually can do something about, and so I work on cancer.
With cancer touching so many lives, this is science for the highest stakes.
We had been working on something that to me was genetic markers and chromosomes and genes and physical mapping and sequencing, and suddenly it was people's lives and people's families.
Bud Romine was told he was about to die of cancer. But today he is alive thanks to a new class of drug created by DNA scientists. It holds the promise of transforming cancer treatment.
That stuff kept me alive and it's keeping me alive right now. There's no question in my mind. Not a bit. Gives me a little long-range view. I bought a new pickup. We bought a newer place down in California. Now, is that optimism or what?
This is the story of a small group of researchers who are developing radical plans to cure the disease we fear most. They're tracing every cancer back to its origins, back to its DNA. "50 years ago, what caused cancer cells to grow uncontrollably was a mystery. These tumor specimens show the devastating impact the disease can have on the body. This is a liver riddled with cancer. The pale bubbles are all tumors, billions of copies of a single liver cell gone haywire. Cells are meant to divide sometimes, but cancerous cells divide far too often. This is a brain. It's been taken over by a tumor the size of a fist. Cancers can strike almost any part of our bodies. 1 in 3 of us will eventually be affected. It's a perplexing disease. Sometimes it strikes at random. Sometimes it runs in the family. The pieces of the cancer puzzle are beginning to fall into place, due largely to our ever-increasing understanding of DNA, the molecule that gives us life. Today we know that when the DNA inside our cells is damaged, our cells can become cancerous. 30 years ago, many scientists suspected viruses might be an important cause of cancer. But a new generation who were interested in DNA began to see the disease very differently. One of them was Mary Claire King. Looking for a new research project, she began to wonder why one of the commonest cancers sometimes ran in the family. It was a key observation.
The strongest risk factor for breast cancer was having had a mother or sister who died of the disease. So here I was, evolutionary biologist coming out of a mathematical background, looking for a hard problem. This was a hard problem.
To King, the pattern meant one thing.
If there's inherited predisposition to breast cancer, it's not anything mystical. It's going to be because of a mutation in some piece of DNA.
The only way to prove it would be to find the mutation, the actual damaged gene. All cancer is caused by damage to DNA. In inherited cancer, the damage is likely to have happened generations ago. The faulty gene is passed to each subsequent generation, leaving a trail of disease in its wake. Mary Claire thought she could find the gene by following this trail.
This is a material substance which will give up its secrets to us if we work at it. We wouldn't know what the gene was. We'd have to go find it. And we certainly wouldn't know what had gone wrong with the gene. We'd have to go figure it out. But I figured we'll cross that bridge when we come to it.
King turned to another DNA researcher, David Botstein, to find out how to start looking for the gene. It seems Botstein was born to be a scientist.
When I was, 9 or 10 years old, I was reading, circuit diagrams and things of this sort for fun. I had a battery and I made little buzzers and stuff of that sort. And I learned about genetics, and that was it. It was love at first sight.
So now, today, things...
When Botstein entered the field, no one knew how to find the genes that cause inherited disease.
There is a class of diseases which is known to be inherited, but very little is known else about its cause. So the question is, could you find those genes? They must be somewhere at a particular location on some chromosome or other.
These are vast lengths of DNA, carrying thousands of genes. The DNA is coiled up, and coiled up, and coiled up. One gene is just a tiny part of the whole chromosome. There are 23 of these genetic filing cabinets in the cell. The gene in question could be anywhere. For Mary Claire, the first step was to narrow its location down to one area of a chromosome.
If we could show that there were some chromosomal bits that were inherited in common by the women who developed the breast cancer, but those same particular ancestral bits were not inherited by the women who had remained breast cancer free until old age, then we might have a clue that those were the chromosomal regions in which, in principle, there might lie a gene that was responsible for inherited predisposition to breast cancer in this family.
What David Botstein had worked out is that naturally occurring variations in DNA could be used to track large chunks of DNA through generations.
Take a family in which cancer is being inherited. Take that family and look at all the parents and the offspring and see if you can find a correlation between a difference in the DNA that has nothing to do with cancer, but is just a difference. A spelling difference is as an analogy which people use, which has no consequence. And we knew that there were such differences.
Even though these spelling differences themselves weren't causing breast cancer, they could be used to identify sections of inherited chromosomes. Botstein called them markers.
So we said, gee, what you could do is take these families and just get markers all over the genome that had these differences, and then after the fact, just taking the families as they walked into the clinic, look for that correlation.
Having constructed this system of markers across all the chromosomes, you could begin to eliminate areas of DNA that were not involved in the disease. If a marker was not shared by all the diseased individuals in a family, you could eliminate it from your inquiries. All the others were possible suspects. To narrow it down further, you studied more families, eliminating all the markers that were not shared between families. By this process, you would home in on one marker shared by all diseased individuals in all families. Botstein reasoned that if this marker was always inherited by everyone with the disease, it had to be in the same region of DNA as the disease gene.
Sort of cool, that not only did people listen to it, but it actually worked.
King had a massive job on her hands. First, she needed to find families with breast cancer.
I was very concerned to enroll as many families as were willing in the project. But how did families know about me? I was a young gal working in Berkeley.
She realized that she would have to go and find them. She needed a place with records, death certificates that could lead her to families who carried the gene. "700 miles away was an organization who kept such records as a matter of faith. The Church of the Latter-day Saints. It was a gene hunter's paradise. The Mormon Family History Library contains millions of microfilm records to help people research their family trees. Here she planned to trace breast cancer families. But another DNA scientist was already leafing through the death certificates. Mark Skolnick.
I'd known Mark from the time that we were both graduate students. We'd both come from backgrounds in math and statistics and thought very similarly about things. We didn't know each other well, but we'd certainly passed through the same meetings from time to time. He was brash and was aggressive, ambitious. But that was 30 years ago.
Skolnick had been the first to see how Mormon traditions could help DNA science.
Mormons keep these records because they have a strong belief that when they die, they will be linked and actually sealed to their ancestors and husbands to their wives in heaven. They've collected this resource to allow everybody in the world to try to reconstruct their genealogies. The Mormon pioneers were polygamists. They would have often 5 or 10 wives, dozens of children, hundreds of grandchildren, and thousands of great-grandchildren. And this allowed us to trace actually up to 10,000 descendants from somebody 7 generations ago.
Skolnick had already traced living relatives of families with a long history of cancer. He and Mary Claire struck a deal. She could have access to his families if he could have access to what she discovered in their DNA. It was a collaboration doomed from the start.
We were both young, aggressive scientists, and both of us wanted to really run the show. As part of what pushes scientists on is the competitive spirit, to want to accomplish something first.
We tried to work together for a while with some of the Mormon families to carry out the search for a breast cancer gene. It didn't work out because I'm a very competitive person and I wanted to get it right and I wanted to get it fast and I wanted to prove that I could do it. Bad chemistry.
It was the beginning of a fierce rivalry. Mark Skolnick kept the Mormon families for himself. But Mary Claire King wasn't giving up. Still determined to find families for her project, she appealed on local television.
They interviewed me. Please, I said, if you are out there and you are a family like this family, please give me a call.
Breast cancer was about to become headline news.
Mrs. Reagan will undergo tests for possible breast cancer discovered during her annual medical examination.
The next day, Mrs. Reagan's breast cancer was announced. So that evening, 128 television stations all around America showed my 30 seconds of, oh, if you are one of these families, please tell me, with my phone number. And we had thousands of calls.
King's first move was to turn the calls into family trees.
So they would talk to me. They would tell me family histories, saying to us, wait, no, I remember Aunt Julie lived to age 80 and she was just fine. And someone saying, oh, Aunt Julie, I thought you were talking about great Aunt Julie. And you get it all straight. It takes days, but it's absolutely fascinating. On this pedigree or family tree, circles represent women, Squares represent men, and filled symbols represent cancer.
With blood samples from the living members of the family, she could finally start tracking down the marker for the gene. She had no idea that it would take 17 years. Day by day, week by week, year by year, Mary Claire worked her way through the completely unknown world of human DNA. A breakthrough came in 1990.
We had looked at 172 markers. You know, the occasional small clue here, the occasional small clue there, but nothing that panned out. And marker 173 looked peculiarly convincing. And bear in mind that, you know, my students have been at this a few years, my postdoc Jeff Hall had been at this a few years more, I'd been at this 17 years. You're not expecting the next result to be right. You're not expecting the next result to fit perfectly.
King had at last found a marker that was identical in everyone who had the disease. But after 17 years, she didn't have the confidence to go public. A chance meeting with one of the original pioneers of DNA science, James Watson, changed her mind.
I met Mary Claire King at a meeting in Spain. And early in life, you know, when people said they have something, I would be skeptical. By then I was, you know, love people telling me good news, you know.
Jim, being Jim, said, "So MC, what have you been up to?" And I said, "Well, Dr. Watson," as I then called him, "I think I've mapped a gene for inherited breast cancer." And his eyes got very wide. And he looked at me and he said, "You've done what?"
Watson realized what this meant. She had cornered the actual DNA damage that caused family breast cancer.
If she had, you know, correctly mapped it to chromosome 17, the next thing was, you know, find out where on chromosome 17 exactly and what was the gene. And I certainly left the meeting with the realization there's going to be a race to find that gene.
Mary Claire had narrowed the search to a tiny part of one chromosome. Suddenly, the world woke up to what she was doing. She was on the verge of solving the riddle of inherited breast cancer. She knew the answer could change lives. It was estimated that 600,000 women in America carried the gene. Thousands of families were living in the shadow of breast cancer. Many were hoping for a test that could tell them who had the gene and who didn't.
You know, there are three reasons people do science: altruism, curiosity, fame.
Whatever was driving Mary Claire, her work was about to take on unexpected significance for one of the families in her study, Family 15. Denise and Vicky were two sisters whose genes were being looked at in King's study. Breast cancer had stalked their family for generations.
My mom was diagnosed with breast cancer in 1978, and then my aunt a couple of years following that, and then my cousin Renee, and then my other cousin Audrey was diagnosed with breast cancer. And my sister Faye in 1984. We were all terrified. And I would go in for my checkups and I would do my monthly breast exams and I would just be terrified and sick to my stomach that I would find a lump like my other family members had found.
It just was such a scary thing for all of us because it seemed like one by one we were all just being told that we had breast cancer. We'd already lost 3 of the young women in our family that were diagnosed, and so it was a very emotional time for us. I remembered sending blood samples to the University of Michigan in hopes of helping them discover some great cure for, you know, breast cancer.
Soon after they gave blood to the study, Vicky's worst fears were realized. She too had breast cancer. For his sister Denise, the diagnosis was the final straw.
I just felt like I was a walking time bomb. It wasn't a matter of if I was going to get breast cancer, it was a matter of when would I get breast cancer.
She made a desperate decision to have her healthy breasts removed.
One day my daughter was taking a bath and she goes, "Mom, I don't want you to go in and have your breasts removed." And I said, "I know you don't, Jennifer, but I really feel that I need to go in and have this done because I want to live."
A week before the operation, Denise and Vicki drove to the hospital. Vicki needed to see her doctor, and Denise wanted to meet her plastic surgeon. The visit changed both sisters' lives. Vicki's cancer specialist was Barb Weber.
There had been a fairly recent announcement that a gene that, when it was mutated, caused breast cancer. And this was a very stunning announcement because there were genes known to cause diseases, but rare, sort of obscure diseases. I was driving home with my husband and I said, I just want to work all the time. I don't want to go home. I just need to work on this.
Weber had teamed up with Mary Claire King's group to help find the gene. As well as treating patients, she'd begun analyzing DNA from families in the Michigan area.
So what I was involved in was a very large group effort to put together the research project that would actually identify that gene.
I went down to talk to Dr. Weber and I told her that Denise was here trying to get some ideas of reconstructive surgery, that she was having her mastectomies the following week.
What Vicki started to tell me about was what her family was like. She was telling it to me from the standpoint of getting me to understand sort of the horror of what the family had been through. They thought of it like the curse of their family. And that was in that context that her stories sort of started to change in my head to the picture of a pedigree, not knowing that they didn't need them.
Weber did not know the identity of the families in the study. But when she heard the sisters' story, she saw it matched family 15.
Now that's we're waiting for that.
Weber realized that they didn't need to find the gene to tell whether Denise needed surgery. If her markers matched Vicki's, who had cancer, Denise too would almost certainly develop the disease.
I'm going to call her and
Denise feared the worst.
he just sleeps. Stephanie just turned 29.
I remember praying the whole way up there because I just felt that I didn't need this, news to go into surgery and have this news that I already had cancer. That's what I actually thought this information would tell me.
I said, "You're not going to believe this after all this time, but we not only know why there's too much breast cancer in your family, but we know who is at risk for getting it and who isn't. And if you want that information, I'll give it to you."
And I said, yes, I do want my information, but thinking in the back of my mind, I really did not want this information.
Well, Dr. Bunn has a study in these.
Denise was the first person ever to be told whether or not she had the breast cancer gene.
Drugs right where we're at, right? Because they're not anything.
And I said, "Well, as you might expect, Vicki, since you have breast cancer, you do have the markers that suggest that you have the gene. But Denise, you don't. It looks like you don't have what it is that's in your family." And everyone just starts crying. Vicki was crying and Denise was crying and, everybody was just crying.
It was a very, very emotional, and it didn't seem, I really felt from what Dr. Weber told me that I should believe what she was saying because it seemed believable, but it did seem like something out of Star Wars that they would actually be able to give me information like this.
I was very, very happy for Denise. And I knew immediately that she had felt the guilt. I didn't know how to stop her from feeling that, but I was very, very happy for her.
It was just amazing. I mean, it was all things sort of all wrapped up together that I couldn't believe that this had happened at a time where we were just thinking about finding the gene, we weren't thinking about this kind of drama.
But for Vicki, there was no salvation.
I, of course, had the gene, and When we did the extensive testing in our family, I found out that my daughter had the gene. And when I first found out that she had the gene, I just wanted to die. I felt so bad that I had given her that gene. And I think that I was first relieved because Denise found out she didn't have the gene. But then when you're dealing with someone that does have the gene, like you said, it is kind of a bittersweet. You have that information and that helps you make better decisions. But you're always wishing that you didn't have it, that you didn't have to deal with it. And now you know really for sure that you do have to deal with it. It's not something you can put off and say, well, maybe it's not going to happen to me.
For women like Vicki and her daughter, the gene itself was the only hope. If it could be found, perhaps it could be fixed. Mary Claire became the most famous cancer researcher in America.
Lord knows we were all working like fiends, given that it was a competition. It was something else. It was just amazing.
King is in a hurry, searching for answers to the mysteries of cancer.
All cancer is genetic. There's no one thing that we can put our finger on.
But Mary Claire's sudden fame awoke another interest. Whoever found the gene could patent it. This would give them exclusive rights to the genetic test. The markets moved in. And the man they backed was Mark Skolnick. He formed a private company called Myriad with the sole purpose of finding the breast cancer gene.
We actually had a competitive edge. We felt we had better information in the large Utah families. I don't think my past relationship with Mary Claire King played a major role in my decision to try to form Myriad.
The idea that a company would actually profit, be able to profit, from gene identification struck me as odd. Clearly, Mark had made the opposite decision.
The King team believed that they would be the eventual winners. They were concerned with who within their group would get the most credit, where we were just focused on sort of catching up and trying to win.
Both sides knew where to look for the gene. It was just a question of who stumbled across the right piece of DNA first.
We all wish for projects that we dream about at night. Everybody in my lab worked quite crazy. My lab was small. The main people on this project were 4 graduate students and me.
When you're in a contest like this, you don't have the luxury of taking a day off or a weekend off. It was like running a marathon race that lasts for 4 years. And so every day you got up, you put on your running shoes, in this case it was an intellectual kind of running shoe, and you raced all day long, and you went to bed, and you got up the next morning, and you laced up your shoes and you ran again.
Those 4 years seem both like a very short period because they flew by so fast, and also there was so much experience and so much thought and so much activity that they're stretched out. Science is like falling in love. Science is like creating art. It's like any other intense human experience that involves the creation and the experience of something you haven't created or experienced before.
The whole of science is an endeavor of taking high-risk projects, and I guess I have genes for risk-taking and wouldn't be happy if I didn't take risks.
King's 20-year quest came to an abrupt end.
The gene was isolated by researchers at Myriad Genetics and the University of Utah.
When I heard Myriad's announcement, I was reading Sequence. And I remember feeling it's been found. Gosh.
The gene that Mary Claire had envisaged as a young woman had finally been found, not by her, but by her arch rival.
A diagnostic test for the high-risk population should be ready in a year or 2. Before this test is cheap enough to be delivered on a general basis, maybe 5 or 10 years.
The high-risk population.
The discovery has made Mark Skolnick a multimillionaire.
Whoever pulled it out deserved to pull it out. I think it was a coincidence that it was them rather than us, rather than Nakamura, rather than Ponder, rather than Lenoir.
When you started getting data that said, I've got it.
But it was them. It had to be somebody, and it was them.
I didn't start Myriad for personal gain. I started Myriad because I wanted to bring diagnostics to the public. I wanted to bring pharmaceuticals to the public. So were we lucky? Were we smart? Depends on the eyes of the observer, what they want to see, what they want to feel about a certain situation.
It's delivery time at Myriad. Hundreds of blood samples arrive. Long after the rivalry and bitterness has been forgotten, these tests will continue to affect the lives of countless women. They receive their genetic destiny in a purple folder. For the lucky, a lifetime of worry is over. For those that carry the gene, surgery and drug therapy can extend lives. Developing genetic tests for inherited cancers is an important step forward in the war on cancer. But most cancer is not inherited. You don't get lung cancer because your father smoked. We pick up the damage to our DNA in everyday life. The real dream is using DNA research to find a cure. Far away from the front line of cancer research is a man who has followed his own hunch about disease for 10 years. Per Lanning is a full-time cancer doctor in Bergen, Norway. Bergen may seem a remote outpost in the global war on cancer, but this one doctor's foresight is changing the whole way we think about cancer as a disease. Over a decade ago, everyone thought Per was a touch eccentric when he began to freeze a sample of every tumor he treated. But he had his reasons. He did it because he was powerless to help so many patients, and he was determined to find out why. He knew that when the right technology came along, his collection would be of enormous value to researchers. And today it is. Per has dealt with the human reality of cancer every day for the last 20 years. The treatment is often as dreadful as the disease. But the problem is not only the side effects, the drugs simply don't work for some patients.
You have to be honest with your patients. How long they're going to survive with their cancers, nobody knows. It's impossible to tell upfront what is going to happen with each individual patient.
Some get better, and others don't. Per's instincts told him that cancer was really just a loose term for an unknown number of very different diseases. So he kept collecting until he could find someone who could help him prove it. The man Per turned to with his tumor bank was David Botstein, the scientist who had devised markers for finding genes 25 years ago. Botstein and his partner, Pat Brown, are pioneering a revolutionary new technique for telling cancers apart. It's called the microarray.
We can use an array.
They believe it can finally reveal the differences between cancers.
The pens dip into
It is an idea so radical, they had trouble explaining it to other scientists.
When I first proposed the design of the robot, how we were going to do our experiments and so forth, when it came back from the reviewers, it wasn't just rejected, it was just like totally knocked out of the park and spat upon and stomped on, and I had to lie down in the floor of my office when I got that.
Yeah, well, we both said that.
You know, now I'm definitely not going to stop until until I've succeeded.
I was astonished that people didn't get it, and when you see that with something which is really good, and everybody hates it, then you know you're onto a really good idea.
The microarray uses genes from the Human Genome Project.
These are the freezers that we use to store the human genes that we use for printing our microarrays. So each of these plates has 96 of these little wells, and each well contains a different human gene. And that collection now stands at about 30,000 different human genes. So this is how we represent the human genome in a microarray. This gives us a way to recognize...
It works like an updated version of a DNA fingerprint. It identifies genetic variation between different kinds of tissue. The human DNA is laid out on a glass slide, one spot per gene. Tumor DNA is placed on top of it, and the two react. The color of the spot tells you how abundant that gene is in the tumor. All the spots together make a unique pattern. The patterns show that identical-looking cancers can have different genetic activities. Today, the microarray and the Norwegian Tumor Bank are joining forces to reveal how many different kinds of cancer there are, helping to explain why traditional treatment is such a lottery. Where doctors see one disease, the microarray sees subtle differences. And these differences determine whether a patient gets better or dies.
These are different women's breast cancers. There are, several different types. 1, 2, 3, 4, 5, maybe 6 types. This represents hundreds of thousands of individual measurements of tens of thousands of different genes. Depending on which kind of tumor they had, they either survived quite well or they unfortunately died.
The hope is that by understanding the genetic basis of a cancer, drugs can be developed to target each one's precise makeup.
What we want to do is we want to match the disease with the cure or palliative treatment, whatever it is, by using the genomic tools. And that's really what the whole cancer world is now going to be about for a very long time.
In the short term, doctors will know their enemy, making cancer medicine more predictable. In the long term, these scientists are convinced that it'll lead to a cure.
The question of whether we're going to break the cure barrier is not the question about if, it's a question about when.
This highly targeted approach to cancer therapy is already beginning to work.
You're doing all right there.
Yeah.
Getting a cramp in your arm.
Brian Drucker is a cancer doctor from Portland, Oregon. Like Pear, he found traditional cancer medicine harrowing.
Here we go. Just take some breaths through that. I took care of a lot of cancer patients, and I remember a lot of them, and I remember that a lot of them didn't make it. If a patient died, we wrote a letter to their family. And in those letters, what I would say is that my goal in my career is to figure out a better way to do this. When we started to learn about chemotherapy, I realized that it could work, but I just could only focus on how horrible it seemed. And it seemed that we were poisoning patients and that for some reason they made it through.
16 years ago, Drucker quit his practice and went back to school to become a scientist. His dream was to find a better way of treating cancer.
I'm not sure I was quite prepared for the shock that I got when I went to the laboratory. And part of it you have to realize is that I had just finished my internal medicine training. I was board certified as an internist. I had just completed my oncology training and was an extremely well-trained oncologist. And so now I went back into the laboratory and I was working besides postdocs and graduate students, and I didn't know anything. So I went from being at the very top of my profession to being somebody who didn't know anything, and these young graduate students and postdocs looked at me as some burden they're going to have to teach.
His ultimate goal was a cancer drug that cured everyone, without side effects. He began working with a Swiss drug company. They decided to invent a drug specifically for one kind of cancer, one where the exact DNA damage was understood. It was called chronic myeloid leukemia.
That's a death sentence. Was then. It was a death sentence. They give me 2 or 3 years is what he gave me. Have some of these. Feed old Abby.
Bud Romine was diagnosed with CML in 1995.
Whistle at
them up. You can do
it. Are you going to start taking real serious thoughts about what you should do with your finances and all this kind of stuff? You know, you got to get things in order.
Yeah, we did that.
And that's really hard to do.
I went over and bought two plots over there in the cemetery. I did do that when I found out. You bet I did.
On the 8th hole of the golf course.
Yeah, it's looking right at the 8th hole of the golf course there. This cemetery's right parallel with the golf course there. There you look right at. Yeah, that's where we're at, all right.
More carrots? Bud won't feel it. It was just a hopeless feeling. What could I do to take it away from him? I mean, could I take some of this burden? Which you can't, but I wanted to. So I couldn't do that, so I had to spoil him. That's all I could do.
We both did some
crying. It was heartbreaking. And all of his medicines, besides...
A year after he was diagnosed, an article caught Bud's eye. It described how Brian Drucker, a local doctor, was working on an experimental drug for CML.
So I wrote him a letter and told him that I had CML, and if and when it came to fruit there, that I'd like to get in on the program.
But now it's known as créé.
Bud was the first man to test Drucker's drug. The clinical trials began at this Portland hospital. The guinea pigs would try out the first drug designed to stop damaged DNA from causing cancer.
And that's what I take right there.
This molecule is the result of the damaged DNA that causes CML. The faulty black section upsets the cell's chemistry, jamming it into permanent division. It was this faulty section that was targeted by the drug. By slotting into it precisely, they hoped the drug would shut down its damaging effects on the cell.
And Bud was the first patient to take this, and it was 25 milligrams.
Yeah.
And there's a picture that was taken of him and Dr. Drucker wishing him luck. So we're pretty proud of that picture. As I just kept...
The leukemia was killing Bud by releasing sudden surges of cancer cells into his bloodstream.
When Dr. Drucker gave me the blood count, I just looked at it, and I couldn't comprehend that those numbers were normal. And he's just standing there grinning at me, and I'm just acting there like I'm dumb or something.
Just happened to read that article. There it was on the front page of the paper. That started it right there. Give you a glimmer of hope at the end of that tunnel. Just a flash down there. And as you go along, it gets more and more and more, and all of a sudden, she widens out, and by God, you're on the other side of the tunnel. And it's a nice, bright, sunshiny day. That's the way I feel.
Oh, mocha. Here, oh, Cody. You want some more carrot? Well, now, oh, see the fence? They don't like
Bud
that.
came within months of death.
No, you just wait, Cody.
But today he's fine.
That's enough, Cody.
The drug cured everyone on the trial.
I first announced some of our results in July of 1999 at a conference in France. And after that conference, I had a few private days on my own. And I really just dawned on me what a remarkable ride this has been. And we really were becoming a part of history.
ST-571 is now called Gleevec. It demonstrates that if you know how a patient's DNA has been damaged, cancer can be cured.
What else have you been doing?
Well, we bowled Sunday and...
My own view is that if you can do it with chronic myeloid leukemia, you can do that with every single cancer. What's unique about chronic myeloid leukemia is not the cancer, but our understanding of it.
Okay, April.
All
Thanks
right.
a lot.
Okay, give my regards to your wife.
Thank you.
Okay, thanks.
At Cold Spring Harbor Laboratories in New York, the goal is to have drugs like Gleevec for all forms of cancer. They've launched a project to find all the damaged genes that can cause the disease. Cold Spring Harbor's top cancer researcher is Mike Wigler.
If my work is delayed by a year, that's, 40,000 deaths. If my work could help treat 40,000 people at some point in the future, in the year 2017, if instead it happens in the year 2018, that could be 40,000 deaths.
Wigler knows that the best way to find cures for cancer is first to find the genes responsible. The reason that Drucker focused on CML, a rare cancer, was because its gene had already been found.
When we're taking our first steps, we found a single human cancer gene, and we studied that for 10 years, finally wrestling it to the ground. We can now do, I'm going to exaggerate, but we can now do in 5 minutes what it used to take us 5 years. And we can now look at 1,000 cancers in a year. When it used to take us, we would do one cancer at a time. So the amplification, the leverage that we have now bought with our technology is dizzying. It's actually bewildering. And sometimes when I start to talk about it, I get giddy.
Wigler is confident that he'll find all the remaining cancer-related genes in the next 5 years. But after that, it's out of his hands.
The drug companies have the power to target cancer genes. It is an extremely expensive endeavor to do this, and drug companies are extremely conservative with their resources. But they have enormous resources. They'll be stimulated by the success of Gleevec. That provides them with some economic model in which to think about these things. But they're also very easily discouraged.
For solid tumors, a more concerted effort will almost certainly be required.
Maybe more than one thing that's needed for solid cancers. They're more complex. They'll have to be treated with a barrage, a regimen of bullets. That'll make the drug companies extremely nervous.
But whether cancer really can be cured depends on how many of our genes cause the disease when they get damaged.
If it's more than 10%, it's probably beyond our control. But I think it's actually less than 10%. And the reason is because of evolution. So, we don't develop cancer when we're 1 year old. We develop cancer, when we're in our late middle ages, by and large, late middle age to late in life. And so evolution has probably gone to work to make sure that these things don't happen. So my guess is that we get cancer because they're frail genes.
Wigler believes that the total number of frail genes that cause cancer when they get damaged is actually very small.
That's extremely good news, because that means compared to the social problems we face, like, the growing gulf between people in the Middle East and people in the West, compared to that, cancer is a solvable problem. And we can't give up the fight at this point, even though it's been going on for a while.
Every month, more cancer-related genes are being found, and eventually scientists hope to complete the list. This knowledge could transform cancer medicine.
You know, our pursuit of all these genes is not just for knowledge of it, but for using this knowledge to stop cancer. We've gone from the viewpoint of not knowing anything about cancer to hopefully not even being an academic problem anymore. That is, be a problem of the pharmaceutical companies. So, you know, I can only wish the drug companies good luck.
There's no such thing as a single cure for cancer. Instead, there will be high-tech drugs tailored for different variations of the disease. Which cancers are tackled first is up to the drug companies. As businesses, they're investing in major cancers with big markets. Since Gleevec, 2 new drugs that work in the same way on more common cancers have come onto the market. Over 100 more are being developed. For people with rarer cancers, the outlook is less clear. For them, a cure may be in reach, but never realized. But even here, there is hope. It rests with the dedication of scientists who realize what's at stake.
Dear Dr. Drucker, my name is John. I am 33 years old. I wanted to sincerely thank you for your commitment in developing STI-571. I know your commitment comes with personal loss, but if only you could look into the eyes of my 2-year-old and tell him his dad was alive today because of your sacrifice, I think you would know it was well worth it. Dearest Dr. Drucker, we are both so thankful to you for discovering this miracle pill. The STI-571 has saved my husband's life. It's been a very hard, bitter battle for both of us, but we are Dr. Drucker, you are my hero. There are no words to appropriately thank you for the difference you've made in my life. You have given me a year of living. Thank you for making me better, and more importantly, thank you for helping me know better than having CML, but it is. Dear Dr. Drucker,
I'll tell you a story. I won't put a name to it. But my wife once had to our house a very brilliant scientist who sat through dinner which she had prepared, saying nothing. And when she finally said to him, "Aren't you going to say something before you go?" he said, "Look, I don't have to say anything. I'm going to cure cancer."
Curing cancer once seemed like an impossible dream. But some scientists now believe they hold the key: DNA.
There are many, very serious problems facing humans, among them poverty and ignorance. And about these problems, we can do very little. But cancer is a problem that we actually can do something about, and so I work on cancer.
With cancer touching so many lives, this is science for the highest stakes.
We had been working on something that to me was genetic markers and chromosomes and genes and physical mapping and sequencing, and suddenly it was people's lives and people's families.
Bud Romine was told he was about to die of cancer. But today he is alive thanks to a new class of drug. To King, the pattern meant one thing.
If there's inherited predisposition to breast cancer, it's not anything mystical. It's going to be because of a mutation in some piece of DNA.
The only way to prove it would be to find the mutation, the actual damaged gene. All cancer is caused by damage to DNA. In inherited cancer, the damage is likely to have happened generations ago. The faulty gene is passed to each subsequent generation, leaving a trail of disease in its wake. Mary Claire thought she could find the gene by following this trail.
This is a material substance which will give up its secrets to us if we work at it. We wouldn't know what the gene was. We'd have to go find it. And we certainly wouldn't know what had gone wrong with the gene. We'd have to go figure it out. But I figured we'll cross that bridge when we come to it.
King turned to another DNA researcher, David Botstein, to find out how to start looking for the gene. It seems Botstein was born to be a scientist.
When I was, 9 or 10 years old, I was reading, circuit diagrams and things of this sort for fun. I had a battery and I made little buzzers.
Created by DNA scientists. It holds the promise of transforming cancer treatment.
That stuff kept me alive and is keeping me alive right now. There's no question in my mind. Not a bit. Gives me a little long-range view. I bought a new pickup. We bought a newer place down in California. Now, is that optimism or what?
This is the story of a small group of researchers who are developing radical plans to cure the disease we fear most. They're tracing every cancer back to its origins, back to its DNA. "50 years ago, what caused cancer cells to grow uncontrollably was a mystery. These tumor specimens show the devastating impact the disease can have on the body. This is a liver riddled with cancer. The pale bubbles are all tumors, billions of copies of a single liver cell gone haywire. Cells are meant to divide sometimes, but cancerous cells divide far too often. This is a brain. It's been taken over by a tumor the size of a fist."
Stuff of that sort. And I learned about genetics, and that was it. It was love at first sight.
So now, today, things...
When Botstein entered the field, no one knew how to find the genes that cause inherited disease.
There is a class of diseases which is known to be inherited, but very little is known else about its cause. So the question is, could you find those genes? They must be somewhere at a particular location on some chromosome or other.
These are vast lengths of DNA, carrying thousands of genes. The DNA is coiled up, and coiled up, and coiled up. One gene is just a tiny part of the whole chromosome. There are 23 of these genetic filing cabinets in the cell. The gene in question could be anywhere. For Mary Claire, the first step was to narrow its location down to one area of a chromosome.
If we could show that there were some chromosomal bits that were inherited in common by the women who developed the breast cancer, but those same particular ancestral bits were not inherited by the women who had remained breast cancer free until old age, then we might have a...
Cancers can strike almost any part of our bodies. 1 in 3 of us will eventually be affected. It's a perplexing disease. Sometimes it strikes at random. Sometimes it runs in the family. The pieces of the cancer puzzle are beginning to fall into place, due largely to our ever-increasing understanding of DNA, the molecule that gives us life. Today we know that when the DNA inside our cells is damaged, our cells can become cancerous. 30 years ago, many scientists suspected viruses might be an important cause of cancer. But a new generation, who were interested in DNA began to see the disease very differently. One of them was Mary Claire King. Looking for a new research project, she began to wonder why one of the commonest cancers sometimes ran in the family. It was a key observation.
The strongest risk factor for breast cancer was having had a mother or sister who died of the disease. So here I was, evolutionary biologist, coming out of a mathematical background, looking for a hard problem. This was a hard problem.